So we want to talk about 11.6 number 1 because Corbin got really far in the homework.
And like way more.
Well, everything is based on
No,
this.
I know. You had a more
It's a really
fundamental
long
question anyway.
day.
So we've got 7x equals 49, and you guys can tell me immediately that x is 2, right? Why? Yeah, kind of common sense, right? We look at 49 and we think that's 7 squared. Then we say, okay, if this is 7 to the something and it's supposed to be equal to 7 squared, then the something has to be 2, right? That's kind of this thought process. Okay, so we get x is 2. Great. What was the rest of your question?
Well, like it's harder if it was 48 or 47 or something. You can't just do that.
Yeah, kind of, what if you had like 7 to the x was 46?
Right, so the actual process behind getting that, aside from common sensing it.
Yeah. So can I express 46 as 7 to the something? I don't know, not right away, right? It's not like 7 to an integer, for instance. So if it's not 7 to an integer, how would I do this same process? Oh, I don't know. We might, what do we really do here? What was the 11.6 idea that we really did? Yeah, we log base 7 both sides. You guys see that? I could log base 7 both sides of this, but there isn't a log base 7 on most of my calculators. So if I want to get a number out of this, I might just log it at random. So by at random, I mean pick one of the 2 buttons on your calculator. So because I kind of do natural things, I might do the natural log of both sides. You guys see that? This is going to give me what on the left? How about this? I get the natural log of whatever 7x is, right? And then on the other side, what am I going to get? Yeah, the natural log of the other side, right? So I'll have natural log of 46. Okay. Now, what was the point? Why did I want to do this? Why was this a good idea, not a terrible idea? Yeah, there's a log rule that's going to help me out, right? I know that I've got a log rule that lets me pull exponents down front. You guys see why this was helpful now? Like fundamentally now I've got the x down. So I've got, after doing the log rule, I've got x times the natural log of 7. Oops, keep writing z's today. Is supposed to be natural log of 46. Okay, and at this stage, this isn't looking tons better, right? Very nice, Zach. You guys see that? Natural log of 7 is just a frickin' number, right? So here I have a number times x is another number. Right? You might like think to yourself, well, if you had 3x is 2, what would you do to both sides? Yeah, you divide by 3. Same crap, right? But think, okay, I'm going to divide by the number on x. So I'm going to get x is 2/3, right? In my kind of thought. Here, what am I going to get? If I divide both sides by, which one was I dividing by again?
7.
Natural log of 7. What's the only thing you need to worry about dividing by? 0? Is this 0? Now there's probably more than one e to multiply to 7, right? Okay, so I divide by natural log of 7. I get x is natural log of 46 over natural log of 7. And
For that written like with a minus sign instead.
Can you rewrite this with a minus sign? This is a false log rule. The log rule that's right there is natural log of x over y is natural log of x minus natural log of y. So what's the difference between this and what I've got happening over there?
You're dividing for you.
Yeah, here I'm dividing on the inside of a log rule of a log, and I'm getting subtraction on the outside. Here I've got dividing on the outside of logarithms. There's no rule for that one. So this thing's as good as it's going to get. What's the other tendency you want to stay away from?
Taking out the natural logs.
Yeah, don't cancel these. You guys see that? There might be some slight tendency to want to kind of cross out natural logs here. You can't do that because
Different bases. Well, different bases, and that's just you're taking out the operation.
yeah, that's just a doing, right? That's just something you have to do to 46. It's not something multiplied by 46. It's something you're doing to 46. You see that? That's a function label, right? You can't just erase function labels. Cool? So if I wanted a number for this, where would I get a number?
Just put it in your calculator.
Yeah, as it stands, this is already kind of a number, right? If I wanted an approximation, though, I could just cram this in a calculator. Don't forget to close that first paren. You guys see what I mean? If you cram this in a TI-83, make sure you close that parenthesis before you hit the divide button. Cool? You have an approximation, Nicole? Yeah, so this is about 2. Why is it about 2?
Close to 49.
Yeah, because 46 is really close to 49. You guys see that? So this is sort of what you would do kind of in practice, right? Because the odds of having 7 to a power and exactly a power of 7 are pretty low. Cool? Questions, Spence? Did that help you out, Corbin?
Yeah, thank you.